Okay, in this video we are going to look at solving rational applications. So we've seen how to do rational equations, and now we're just going to look at some applications of them. And I think we'll just look at three major ones. So the first one is something known as the work principle. And the work principle, just like it says here, is if you've got two people, one person takes a certain length of time to do a job, another person takes a different time to do that same job, then how much time would it take them to do that job together? And here's the formula down here below that shows that. The T represents how much time it would take both of them to do it together. The A and the B represent how much time it would take the one person or the other person. One thing just to notice about this too, like if you had two people and one person took 10 hours to do the job and the other one took 10 hours to do the job, then together it would make sense that they could do that job in half the time, right? But if this person took, say, 8 and this one took 10, then you've got to find a number sort of in the middle there. It wouldn't, like, would it be 4.5 hours or just how much? This formula helps you do that. So here's an example or two. Contractor finds takes Megan 6 hours, James 8 hours. So how long would it take them if they worked together? So here's our formula. T over A plus T over B equals 1. You can also use this other formula, this one, and they work out to be the exact same thing. So whichever formula really works for you. I've become accustomed to using this one, but either formula will work. Okay, total time for both of them, one person, the other person. So let's plug our numbers in. So how long will it take them if they work together? That's what T is. So T, I don't know, over how much time for Megan, so it'd be 6, plus T, don't know how long it takes them both to do it, over James is equal to 1. And now I've got an equation with one variable that I can solve. So I will, if I'm solving a rational equation, first thing I need to figure out is what a lowest common multiple is. For 6 and 8, I believe that's 24. We've done that one a few times. So I can take each term, t over 6 plus t over 8 is equal to 1. I can take each of those terms and multiply it by 24. Just like we did in the last section. So any kind of equation, if it's rational, you can use this to help you get rid of the fractions. That's its main job. Okay, so 6 goes into 24 4 times, so this would be 4 times t, plus 8 into 24 goes 3 times t, is equal to 24 times 1, or 24. Now, this equation here, I looked at it and went, how do I solve that? As soon as I use this I hate fractions principle, now I've got an equation that is like, oh, I know how to do that. I'll add these two, so that's 7t is equal to 24, and then I'll divide both sides by 7 to give me 24 over 7. If you divide that, that's going to be 3 3/7, or not quite 3.5 hours. So one person took 6, the other person took 8. Together, it would take them 3 3/7 hours, almost 3.5 hours. Here's another application of the same thing. But this time I've got 3 people doing the job, and it turns out that the work principle is extendable like that. You could have a ton of those. So if they work together, how long would it take them to paint the room? Maybe take a guess at this one. So 6, 10, and 8. You got 3 people working. If you, I don't know, as long as they're not running into each other and losing time, maybe 2 or 3 hours. Let's see. So here's our formula. T over 6 plus T over 8 plus T over 10 is equal to 1. I should make my T a little curly so it doesn't look like a plus. Okay, LCM. 6, 8, and 10. I might have to do that with the 6 is 2 times 3, 8 is 2 times 2 times 2, and 10 is 2 times 5. So I'd need 3 2's. I'd need a 3, and I'd need a 5. Is that right? Yeah. So it's 8 times 15, 120, I think. Is that right? 10, yeah, 120. So I need to take each term, t over 6 plus t over 8 plus t over 100 is equal to 1. Each of those terms, and multiply it by 120. 120, 120, and 120. And always don't forget to do the terms on the other side too, if there are some. Okay, 6 and 120 goes 20 times, I think. So that'll be 20t plus 8 into 120 goes 15 times, I think. So that would be 15t plus, well, that I put 100 there. It's only 10. 10 into 120 goes 12, so that'd be 12t is equal to 120. So now add these together. 35 plus 12 is 47. T is equal to 120. And then divide both sides by 47. So T is equal to 120 divided by 47. And let me bring up my handy dandy calculator. Handy dandy calculator. 120 divide 47 equals 2.55, call it 2.6. So about 2.6 hours for all three of them to work on the same job. Okay, you know, there's one question, and I didn't put this in there, but it might be a nice question to look at, and something like the question where it says one person does the job in, say, 6 hours, then together they do the job in 4 hours, and then the question would be, how long would it take, let's say one person, let's call them A, and then person B, you don't know how long it takes them to do the job. And then the question is, so how long would it take B to do the job by themselves? So alone. I should have done one like that. Well, but let's try it. So T over A plus T over B is equal to 1. This time, you know that together it takes them 4 hours. So that's what the T is. So it would be 4 over A, they do it in 6 hours, okay, plus 4 over B, you don't know, so that's my variable, is equal to 1. So there's an equation where this time your variable that you're looking for is on the bottom, and that might be worth it to try solving that one. Okay, so it's a rational equation, so I need to find an LCM. My LCM will be, there's a 6 and a B, so my LCM will be 6B. I should have picked another number other than 6. It looks like 66, but that's a B. Okay, so I need to take the 4 over 6 plus the 4 over B is equal to 1. Take each of those terms and multiply them by the lowest common multiple. So it's 6B. Now it looks like a P. And then this one, 6B, and this one, 6B. Okay, so in this one, the B's cancel out. No, the 6's cancel out. That's a 6, yeah, 6's cancel out, and I'm left with 4B. Okay, plus, this time the B's cancel out, and I'm left with 6 times 4, or 24, is equal to 6B times 1 is 6B. There, that's better. Now, collect my B's. So I'd leave the 24 on this side, and I'd move the 4B over to the other side and subtract. I should have used a different letter. Okay, and then 6B minus 4B would be 2B is equal to 24. And then divide both sides by 2, so I get B is equal to 12 hours. So One person takes 6 hours, together it takes them 4 hours. So the other person is actually a whole lot slower because to do the whole job by themselves, it would take them 12 hours. That's another good kind of question, emphasizing the same thing of solving a rational equation. Here's another example of a rational equation, or one that you can get rational equations with, and that's motion. So using the formula distance is equal to the rate of speed multiplied by the time it takes them. And that's a nice one. I'll just go through maybe one or two examples of that. So Tanner drives 20 kilometers an hour faster than his mother. In the same time that Tanner drives 90 kilometers, his mom drives 60 kilometers. So the question is, how fast are they going? So I can use a nice little table here to sort of indicate information for each person. And I like how the textbook does this. So Tanner's driving 20 kilometers faster than the mother. That's under rate. So if the mom is driving, say, R, and we don't know how fast, that's what we have to find out, then Tanner's 20 faster than that. So that would be R plus 20. Okay? In the same time that Tanner drives 90 kilometers, so Tanner drives 90 kilometers, his mom drives 60 kilometers. But they said the same time. That's an important piece right there, the same time. So here, the time for each of them is the same. Maybe we'll just call it, I'll use a different color. We'll just call it T. So if I have this information, I can determine, as long as one of those units is the same, I can determine what these other ones are. Let me show you how you would do that. So if the time is the same, then what I'm going to do is solve this formula for t. So I'll divide this side by r and divide this side by r. When I do that, here the r's cancel, so I'm left with t is equal to distance over the rate. So, and this is what I was going for, is time, because time is the same thing over here. So I solve this equation for time. Now, the time that they take is the same. So if I were to write this formula, the time for Tanner is equal to a distance over a rate. And the time for the mother is equal to a distance, I guess the distance that the mother travels, divided by the rate that the mother travels. Over here I could have used T for Tanner, his distance and his rate. But the time that Tanner takes is the same as the time that the mom takes. So this and this are the same. So it means that this one and that one are the same. So if those two are the same, then the distance that Tanner takes divided by the rate that Tanner goes must be equal to the distance that the mom goes divided by the rate that the mom goes. Just a little bit of mathematical play in there. But that's sound kind of logic to be able to follow. Okay, so distance that Tanner goes, distance that mom goes. Let's put those things down here. I can't see my sheet up there at the same time. Maybe I'll write it over here. Distance that Tanner goes is 90. Divided by Tanner's rate, he's going his mom's rate plus 20, is equal to the distance the mom goes, 60, divided by how fast she's going, r. There we go. So here, then, is a formula that I can use that only has one variable, and so I can solve for that variable. Let me just write it down again over here. So 90 over r plus 20 is equal to 60 over r. Now, what I do here is, it's a rational equation, so I have to find the lowest common denominator, or lowest common multiple. This one has an r plus 20, this one has an r. So what I can do is I can multiply both sides by the lowest common multiple, which will be r plus 20 times r. So I'll multiply this side by r plus 20 times r, and I'll multiply this side by r plus 20 times r. Some of you might say, well, why don't you just do cross or cross multiply and divide? You certainly can do that, and that's the same thing. But cross multiply and divide is based on this principle that you can multiply both sides by the same thing. And notice that what's going to happen is the exact same thing that you get with cross multiply and divide. So here, r plus 20 cancels, so I'm left with 90 times r on this side is equal to, on this side the r's cancel, so I'm left with 60 times r plus 20, or 60r plus 1200. Okay, if you just distribute that through. Okay, collect my r, so I've got 90 minus 60 would be 30r is equal to 1200. Again, I skipped a step in there. If skipping that step bothers you, go ahead and put it in. 90r minus 60r is equal to 1200. So you're basically subtracting 60r on both sides. Put steps in if you need to. Now divide both sides by 30 and you get r is equal to 40. So what is r? Let's go back up to our table up there. R, right here, was how fast the mum was going. So if they want to know what the speeds are, Mum was going 40. And Tanner's going 20 more than that, so Tanner'd be going 60. So this would be the Mum's speed, and Tanner, he would be going 60 kilometers per hour. Okay, that's a good application for rational equations, that one. I like that one. Here's another question, and it's the same kind of thing. It would be speeds. I won't do this one, but you can maybe try that one on your own. And there's some examples in the book too. The last example of rational expressions would be involving similar triangles. This is basically using a ratio to solve something. You need to know the definition of similar triangles. Similar triangles mean they're the exact same proportion or the exact same shape of triangle. Or in other words, like I said over here, this angle is the same as this one, and this one's the same as that one, and this one's the same as that one. If all those angles match up, that they're identical, then all of these sides will go in the same proportion too. Like if this one was 10 and this one was 5, it looks like these are half. So then if this one was, say, 16, this one must be half of this one. Okay, so all the sides are in proportion to each other. So if they're in proportion to each other, you could make up a formula like C over Z is equal to A over X. Okay, C is to Z as A is to X. Or you could have it, let me go down a bit. You could have B is to A, B is to A, the same as, what do you think? This and this go together, so Y and X would go together. Sure, that could be a proportion or a ratio that you could make with, I guess it's a proportion with those triangles. So any side, as long as you stay consistent with what they are, you can make up a formula for any of those. Here's just a simple example of one, is a ladder. So you've got a ladder, you've got a wall, and you've got a ladder. Okay? And it says when the ladder's at 5 meters, it reaches up the wall 4 meters. And then they say if I extend the ladder to 7 meters, keeping the same angle, sorry about my line, keeping the same angle, if you extend the ladder 7, then the question is how far up the wall do they go? So I've got two triangles. Let me draw both of them. So I've got this one where the ladder's 5, it goes up 4, and then I've got another one where the ladder's 7, and I want to know how far it goes up the wall. Just see if they're similar triangles, and the key to that is if they keep the same angle. If they're similar triangles, then I can use proportions to solve that. So I can say this side is to that as this one is to that. Or I could say this one is to this as this one is to that. As long as I keep them in consistent, I'm good with that. So I like to go this one to this one. So 4, the height of this one is to the height of that one, which I don't know, is equal to the ladder over the ladder on this one. Okay, now I've got a proportion here, and again, it's a rational equation that I can solve. Maybe I should put a letter for this one. Let's call it P. Okay. I can look for a lowest common multiple. It's a P and a 7, so my lowest common multiple will be 7P. So I'm going to take each side. I'll take the 4 over P, and I'll take the 5 over 7. Take this side and multiply it by 7P. Take this side and multiply it by 7P. Again, you can use cross multiply and divide, but that's based on this principle. Okay, on this side, the P's cancel, so I'm left with 7 times 4 is 28. On this side, the 7's cancel, so I'm left with 5P. Now, a nice, easy equation to solve. Divide both sides by 5, and you get 28 over 5, or that'll go into there about 5.6 times. Yeah, about 5.6 times, I think. Yeah. Divide that, so the ladder will reach up, instead of reaching up just 4 meters, it'll reach up 5.6 if you extend the ladder. Okay, so in this section, we've looked at 3 examples of rational expression. We've looked at the work principle, T over A plus T over B is equal to 1. We've looked at a distance, rate, time example. And lastly, we looked at some ratio examples, specifically similar triangles. Try some questions in your book.